Starting with the bullet head, move into the neck, then the shoulder. We have the casing body, then the casing rim down here at the bottom. Underneath, we have the primer pocket. There's a breaking point to brass. So this is the limitation of casings nowadays, is I have a known point. It's been scientifically proven in labs and everywhere else where this will fail. Certain thickness, it will fail at a certain point. So we've pretty much, as firearm technology, have met the maximum point with the propellants that we have on brass cartridges. You have steel cartridges now that can take a little bit more, but the problem is you run into feeding problems. There's also problems with the gases. It doesn't expand the same as brass. So there's polymer cartridges now that potentially could, maybe if they are woven with some Kevlar or something like that. There's a lot of interesting things that NASA uses for going up to possibly 250,000 psi Kevlar woven polymer hoses to feed the engines of different rockets. Now something like that technology could turn around and come into play if we could incorporate it into a case, and that could lead us to where we could have the same size projectile with a polymer woven Kevlar case, and then be able to have the same grain weight of powder, but a new formula that potentially has greater expansion and can go further. But brass is limited. We can't get any more out of it, from my opinion, than what we're doing right now, because we would have to increase the thickness of the brass to increase the chamber pressure. Most barrels, we can modify those with different hardened materials, but brass, I mean, if you want to shoot a 7mm, you're pretty limited to what size casing you're stuck at. Headspace is defined as the distance measured from a closed chamber's breech face to the chamber feature that limits the insertion depth of a cartridge placed in it. Okay, let's talk about how straight-walled modern cartridges head spacing. So unlike the shouldered case, 223, the 9mm, and then also I have a brass from a 350 Legend. Where's the head spacing going to be measured from? It's going to be measured from the mouth, right here, from the very top. That's where it's going to seat, from the rim all the way up to this mouth. Same with the Luger, the 9mm Luger. It's going to get right there on the mouth is where it's going to seat and going to be holding all that pressure. Not a lot of material there. So again, that goes into what are the limitations of these rounds. I mean, if I increase the chamber pressure of this round, is it going to be able to withstand this little bit of material for the head spacing, holding everything back? So, I mean, that's why it's the problem with straight walls, and that's one reason why we have these bottlenecks now, because they're able to increase the pressures by having a smaller bullet than the straight wall casing. These two rounds are exactly the same in terms of their case. 350 Legend and 223 are similar rounds. They both can be fired out of the same bolt. But, I mean, of course, the barrel's different, right? I mean, you're going to have a larger diameter. Now, granted, the 350 Legend is going to have a larger grain rate, but lower velocity, because you've got more powder focused on this 223. So when you're doing the head spacing, right here on the shoulder to the rim, straight walls from the mouth to the rim. Now, there's a lot of limitations on these casings. I mean, in terms of pressures. Once you exceed a certain pressure, the case is going to fail. Now, they have different alloy materials and formulas to make these cases a little more elastic, so they can expand a little bit and come back into fruition. But there's always limitations.